We need to make sure that we have the proper amount of water, not just pressure, to put out the fire. Water pressure is important. It gives us the reach and penetration we need to get to the source of the fire. But getting the right volume of water on the fire to absorb the BTUs it is generating is what actually puts the fire out. So we must ensure there is a steady supply of water arriving on a fire ground to beat back the enemy. We must then know something about water and its characteristics. That is why we're going to discuss hydraulics. Hydraulics is the study of how we move water on the fire ground. We could talk about hydraulics all day long. In fact, I am well versed in the language and technical understanding of hydraulics, as I was a fire protection engineer as well. I didn't always wear a white hat. There are many formulas and calculations relating to discharge flows, friction loss, K factors, and such. For this discussion, we'll talk about the basics of hydraulics and its practical application to the fire ground and to water supply. A fire hose stream is basically a closed system. With the nozzle open, the water that goes into the inlet must come out to discharge. But there is a limit to how high a pumper can send water or how far it can push it. Here we have a Class A pumper rated to deliver 500 GPM at 250 psi with an adequate water supply connected to the intake. At ground level, it will have no problem delivering that 500 GPM to the attack line. If the pumper needs to push that same 500 GPM up a standpipe at a 60-story office building, it will fail. Even without taking into consideration friction loss, which we'll talk about very shortly, there is mathematically not enough pressure available. Remember that every PSI gives us 2.3 feet of elevation. Multiply 250 times 2.3, and we can see that this pumper can only push the water up 575 feet. That is below the 600 feet needed for the fire on the 60th floor. Another partial solution is to lower the volume required by the nozzle, so that the 700 GPM supplied by the two-line system matches the nozzle's flow. If the master stream were changed to an 1.5-inch tip, the 700 GPM would produce 120 psi at the nozzle. This would give you plenty of reach and penetration, but be aware it did not increase volume. If the fire needs 1,000 GPM to put it out, and you're only hitting it with 700 GPM, the fire still wins. This is another drawback to using automatic nozzles on master streams. It's hard to tell when the volume is being compromised. The stream from an automatic nozzle at 700 GPM looks just as good as it does at 1,000 GPM. There's no nozzle man to feel the decrease in nozzle reaction. Again, volume wins the fight. Don't just crank up the engine pressure and hope that the PSI will do the job. If you need more volume, run another line.